All right, so they give us this differential equation, dy dx equals all of this. It says find the second derivative in terms of x and y. All right, so that's not too bad. So we are going to do the derivative of what we've got here. So that would be 2x minus, or I guess I should put second derivative equals. I think they would still give it to you, but let me be like real particular here. So second derivative equals 2x minus 1/2 dy dx. And then just in place of dy dx, you're going to put this whole statement. I feel like when you find second derivatives of differential equations, it's redundant because you end up plugging in for dy dx, which is the thing that you just took a derivative of. So it's 2x minus 1/2 times all of this. And that is our second derivative. So let me see how many points that was worth. I think that was worth 2. Yeah, that was 2 points for that. All right, letter B, let f of x be a solution to this differential equation going through the point -2, 8. Does the graph have a relative minimum, maximum, or neither at -2, 8? All right, we are going to look at the first derivative at that point and the second derivative at that point. We're going to do the second derivative test. So we're going to do the first derivative at the point -2, 8. And so we're going to plug in -2 for x and 8 for y. So that would be 4 minus 4, which would give us 0. So what that tells us is that this is a critical point. So if your derivative equals 0, then we know that that is a critical point. And then when we do the second derivative at that point, that's going to tell us concavity. If it's positive, it'll be concave up, negative, it'll be concave down. So here's our second derivative. Again, we're going to plug in -2 for x and 8 for y. So that's going to be -4 for that first part, minus 1/2 times, and then let's see, this would be 4 minus 4 would be 0. So actually that whole part goes to 0. And so it comes out to be -4, which means that the graph is concave down. So if your graph does something like this, if it's concave down, where you have a critical point, you're going to have a relative maximum. So that's our conclusion, and we're going to just write that out in words to justify. So f of x has a relative maximum at this point, -2, 8, because the first derivative at that point was 0, and the second derivative at that point is negative. I usually write is negative, but I ran out of space at the edge of the paper, so I just put less than 0. But you could say is negative. I tend to prefer that better, but I just kind of ran out of space at the edge of the paper there. And I think that was 2 points as well. Yeah, it was 2 points. Let me see how they worded it. I don't know that they broke it into 2 separate points. Let me see. Yeah, it just says 2 points conclusion with justification. So that sounds like it's 2 points all or nothing, which is really kind of a bummer. It's nice when they break it and give you like a point for something and a point for something else, but it just says 2 points for the answer. All right, and then letter C, let g of x be a solution to that differential equation with this initial condition. So -1, 2. Find limit as x goes to -1 of all of that. Show the work that leads to your answer. Now you're going to need to do limit as x goes to -1 of the numerator and denominator separately, because spoiler alert, it's going to go to 0 over 0. And you can't ever say that something equals 0 over 0, because that's not technically a value. So we're going to do the numerator, and then we're going to do the denominator separately. And usually if they ask you to do something like this, it's going to go to 0 over 0. We're going to do L'Hopital's rule. So here, if we plug in -1, they told us g of -1 is 2. So that's going to be 2 minus 2, which gives you 0. And here, if you plug in -1, you're going to get 0. So you have to show that in order to do L'Hopital's rule. And this is going to be a little bit redundant with the recopying, but you have to rewrite this because you have to link these together. And you have to say that that equals limit as x goes to -1 of the derivatives. So we're going to do the derivative of the numerator and derivative of the denominator. It's not a quotient rule. We're going to do them separately. So for the numerator, that'll just give us g prime. -2 is a constant, so that's gone. And then down here, we'll bring the 2 down, so it'll be a 6. That'll drop to a 1. You can put the 1 there if you want. And then there would be a chain rule. You would chain on the derivative of x plus 1, but that would just be 1. All right, spoiler alert again. This is going to go to 0 over 0 again. So we're going to, again, have to do these limits separately. So we're going to do limit as x goes to 1 for g prime, and then limit as x goes to -1 for this denominator. And that one's real easy to see. That's just going to go to 0. But g prime, that's the derivative, which is this right here. That's our dy dx. So we're going to plug in, it was -1 for x, and then what did they say? Y was 2. So we're going to plug in -1 for x and 2 for y. That's going to be -1 squared minus 1/2 times 2. That would be 1 minus 1. And so that goes to 0. So again, this goes to 0 over 0. You just have to show the numerator and denominator separately because you can't say that something equals 0 over 0. So we're going to do L'Hopital's rule a second time. I promise it's going to work this time, though. Derivatives of the numerator and denominator. So the numerator will be the second derivative, and the denominator will just be 6. So that can't go to 0 because that would just be the number 6. All right, so now we're looking at the second derivative, which we found back in part A. So this is our second derivative, and we're gonna, again, plug in -1 for x and 2 for y into this second derivative. And I'm sorry, I don't have enough space here. So again, it's -1 for x, 2 for y into this second derivative that we found in part A. So that is gonna be 2 times -1 minus 1/2, and then -1 squared would just be 1, and then minus 1/2 times 2 would be 1. Again, it was the point -1, 2, and then over 6. And you don't have to simplify that down. You can just leave it like that. All right, so points for this, it was 2 points for doing L'Hopital's rule. But I don't think they would give you that unless you showed all of these derivatives going to 0. So it's kind of 2 points for all of that, and then a point for the answer. All right, and then D, let h of x be the particular solution with this initial condition. So 0, 2, use Euler's method starting at 0 with 2 steps of equal size to approximate h of 1. So Euler's method isn't hard, you just have to remember it. Kind of like everything else in BC calculus, there's just so much that you have to remember. Euler's method, we're going to make a table for x and y. So it said to start at 0, 2. And we want to get to 1, we want to approximate h of 1 with 2 steps of equal size. Okay, so if we want 2 more steps and we want to end up at 1, we're going to have to count by 1/2. So 0, 1/2, 1. So the way that you get the y value is you take what you started with, which in this case is 2, and you add on the step size, which is 1/2, the length of the interval, times the derivative at the previous point. So it's the derivative at 0, 2. So here's our derivative. We're going to plug in 0 for x and 2 for y. So that would give us 0 minus 1. That would be -1. So this is 2 minus 1/2 which would be 1.5 or 3/2. And then when you go to the second one, it's the same thing. You take what you were just at. It's like you go back to the previous one and you add on the step size times, I'm going to leave a little bit more room here. You want the derivative at the previous point, because this is going to get messy with the fractions here. So we're going to plug in 1/2 for x and 3/2 for y in this derivative. So 1/2 squared would be 1/4. And then 1/2 times 3/2 would be 3/4. And I guess technically you can leave it like that. I guess technically you don't have to simplify that down. And they were having us approximate, gosh, what was it, h of 1? Yeah, that's approximately h of 1. That just occurred to me because usually I sift through all those fractions and simplify it down, but I guess you wouldn't even have to. All right, it said 1 point for doing Euler's method, which I guess would be like making the table, and then 1 point for the answer.